microphone's not working. I don't think the microphone, oh, it's working. Okay, very good. Thank you for the introduction. It is a pleasure to participate in Seoul for TechPlanet 2016. I'm going to be giving you an overview of our Watson technologies, and we have over the past year and a half factored them into a number of services so that developers can choose and compose the right services for the applications they want to build. So first, I'd like to start with one of the services, which is a text-to-speech service.
Hello, my name is Watson. My colleague is here today to describe natural language processing and discuss how I learned to process the Korean language. We hope you enjoy the experience. Now, let me introduce your guide for today, Salim Roukos.
So these services are available on the web, and I'm going to show you some more of them as we go forward in the talk. We refer to these services under the umbrella of cognitive computing. These are systems that are able to train through education. So this is technology that's based on machine learning, where you teach the system how to do a task. And they support, in a fundamental way, the expression of natural language. This is important for many reasons. The first one is we humans are very effective in communicating by using language, so we would like to talk to our systems. And the other reason is there is a lot of knowledge in the world which is written as written language. So if the computer can understand the written language, it can collect information and use that information to help users answer the questions of users. And the third element is if you focus the training of the cognitive system to a specific domain, and if you train it with very advanced data, it can become extremely expert in that very specific use case. So a computer system can be as good or better in some cases than the experts in that domain, which means that average users can interact with a cognitive system and be as knowledgeable as an expert user. So this notion of an assistant is an important element of many cognitive systems. And the final fourth point is these systems continue to evolve. So it's not that you build it once and you leave it. You keep training it. As it's being used, you analyze what's going on and teach it additional functions or more robust functions. And obviously, they can do this at a very large scale. They're computer systems, so they can handle large volumes of data. This is different from traditional computing, where people used to build a piece of software by writing rules. And one of the challenges with these rule-based systems is they tend to be brittle, which means that if the input is a little bit different than what's expected, it typically does not do anything. Whereas with machine learning-based systems, because there is a notion of a confidence score, they typically can answer questions that are a little bit outside the expectation of the domain. And the other thing I want to highlight is instead of writing rules, cognitive systems require a lot of training data. So I think the price one has to pay is to provide sufficient amounts of data to get the performance that's required. So it gives you more value, but you need to train it. I'm sure you've heard of the famous Jeopardy system. This is the first Watson system that was used in 2011 to play a game where the questions are short questions, and more importantly, the answers were factoids, which means it's 1, 2, or 3 word expression. It's a very short answer. And that system was able to process a lot of content, about 200 million pages, and it was at the time very fast, but used a lot of computer nodes. It was, code that used a lot of computing, but because the game required answering questions quickly, it was necessary to have a lot of computing to get quick response times. Since then, the system has shrunk dramatically. The amount of hardware required is much, much smaller to perform the same task. Now, I said Jeopardy has relatively short questions, maybe 10 words, 15 words is the question, and the answer is 2 or 3 words. There are other domains where the question is much longer. So this is an example of a Watson system in healthcare. Here, the input is the medical report that a doctor issues about a patient. And it's color-coded. The regions of text that correspond to certain semantic types, such as symptoms, family history, personal information, medications, and findings, are color coordinated. So the computer system has to analyze this very long question or piece of text, and based on this analysis, infer and make recommendation about what to do for the patient going forward. So for example, Watson has been developed over the past 4 or 5 years now in healthcare, and we have worked with a number of leading US medical institutions such as Cleveland Clinic, MD Anderson, and Memorial Sloan Kettering. And based on their expertise, we taught Watson how to analyze the case of people with cancer for oncology. There is a recent TV program called 60 Minutes in the US, which gave an overview of Watson for oncology with University of North Carolina. And I have the link at the end of the talk. You can go look at it. The most interesting thing about that piece of video is it shows that in 30% of analyzing real patients' histories, Watson was able to suggest new treatment options that the expert did not discover on their own. So it's a tool that helps the oncologist find possible solutions. And the reason it can do that is there is about 8,000 articles per day, every day, in that field. So there is no way doctors can keep up with the information. Whereas a Watson-based system is able to keep track of that information and therefore be able to be more up-to-date in its recommendations. Now, I want to talk a little bit more about how we factored the big Watson system into a number of services that are available on the cloud. And the cloud we call Watson Developer Cloud. And if you go there, you will find a list of services. I'm going to describe a couple of them today. So the first one is Personality Insights. If you feed it the Twitter feed of a person, say about 4,000 words of their writing, it will create for you a personality profile of that person, of that writer. And that can be useful to give you insight into what kind of person it is. And depending on the personality profile, you might choose to do the advertising differently. Some people are more amenable to advertising. They can tolerate more advertising than others. So there are lots of intelligence that can be done with the personality profile service. We also have language identification, machine translation, speech to text, text to speech, which I showed you earlier, visual recognition. If you have an image, you can get tags of the image. And I'm going to talk a little bit about conversation later in this talk. But there is also what we call tone analyzer, which analyzes the human state when they're interacting with a chatbot or with a computer system. You want to detect if the user is unhappy, happy, angry, upset with the system. So this notion of tone detection is becoming more important as we go forward with chatbots in commerce and self-service applications. Then I'm going to describe in more detail today the natural language classifier, which is a particular technology that helps find answers to questions. And I'm going to talk also in detail about alchemy language relationship extraction, which is how do you analyze text to extract content from it in terms of a type system like I showed earlier for the medical electronic health record. Obviously, these services are available on our Bluemix Cloud, IBM Cloud service, and they can be combined with other Bluemix services. So these are the Watson Developer Cloud cognitive services, and they can be combined with other Bluemix services to build more general purpose solutions. So I'm going to spend I'm going to spend some time on two specific cognitive services. The first one is the natural language classifier. Its primary use is to take a short piece of text, 10 to 15 words, and associate with it a class label. And this is particularly useful for question answering, as I will describe in a moment, but it can be used for other applications such as classifying Twitter messages, sentiment analysis, and what's called dialogue act classification. This particular service can be combined with other services like dialogue, speech-to-text, to build maybe a speech-based conversational interface or a chat-based conversation interface. So there is a way to compose these services to build different types of solutions. I think you saw this chart earlier in the first talk, which is if you have a bunch of potential queries or questions from users, there are questions that are repeated a lot of times. It's called the head of the distribution. This is where the NL classifier is particularly useful. If the confidence of the classifier is not high enough in its answer, then you want to use what's called the long tail, and that's more the traditional search technology at play. We call it retrieve and rank, and more importantly, this is a trained engine. You can train the retrieve and rank engine to the specific domain that you are working on. And these two can be combined with dialogue to interact where context can be important. Sometimes the user may not give you the full information required to answer his question, so you can prompt them for additional information, or you can use context to interpret additional questions in the conversation. So let me talk a little bit more about the classifier in a little bit more detail. So the idea is when you want to build a classifier for a domain, you have to identify the head of the distribution, which are the most frequent intents. And what I mean by intents are the actual type of answer the user is looking for. So for example, in this slide, I'm showing how do I get a new password. This would have the same intent as reset password. Or I could say, as a user, forgot my password. I really have the same intent again. Or I can say, I can't remember my password. I have the same intent. So the idea is to find all possible questions from the user, map them to their intents. And in the general case, you will have many intents, maybe 1,000 or a few thousand, depending on the use case. Many use cases can be handled with few hundred intents, actually, based on our experience. And once you have the intents mapped to the questions, you can push a button, train a system, and you have a classifier to handle this use case. And separately, you can map an intent to an answer. So notice now, the answer can change without the system changing. So this decoupling is very important and helpful. And answers don't have to be a piece of text. They can be an image, they can be a database lookup, so it can be a very rich type of answers, where we have separated the natural language processing on the front to map to intent versus producing an answer from the intent. So I'm not going to get into the algorithms, but the fundamental concept is you learn about a word by seeing in which context it's being used. So it uses deep learning technology to do this classification task. We also have generalized our system from being English only to lots of languages, and I'm going to talk a little bit about that. We've worked with a number of partners to do multiple languages. The most recent language is Korean. We're doing this in partnership with SK. So typically for a new language, we need to add a language-specific module, which means take the input characters in that language, analyze the language. In some languages, you have to find where the words are. Sometimes you have to break a word into pieces that carry the fundamental meaning in that language. We call this for morpheme segmentation. Then you can do parsing, who did what to whom, subject, verb, object. So we have a front-end natural language module that's language-specific. And then the rest of the pipeline is general-purpose language-independent pipeline. So to help us in our work in porting Watson to the various languages and making sure that it's working well in each of these languages, we used one canonical use case. So we have a domain. It's called Watson on Watson. You can ask questions about Watson. We have it in English. This used to be a demo in English. We build the same training and test content in all the languages that we are pursuing. So now we have a comparable task across all the languages. So we have about 2,000 training questions, about 350 test questions, and we measure the accuracy of the system for the same test set, but in each language correspondingly. This way we can compare across languages. And for example, these are some of the questions of the Watson on Watson domain. How long does it take to get Watson? How long does it take to train Watson? How many servers does Watson use? And so on. We have the same in Spanish, have the same in Arabic, we have the same in Korean. And then when we train these systems and measure the performance, you can see the performance is equivalent across all the languages. So there's nothing particularly hard or difficult about any one language. I mean, each language needs its own special work, obviously, but as a general rule, we get the similar performance across the languages. So now I'd like to give you a demo. You could maybe type a query into the search engine, the retrieve and rank engine, who is the CEO of IBM, and search it. And when you do that question, maybe, if I'm online, did I not verify that I'm online? Okay, I'm online, so that's good. So it got an answer, and the reason it got this answer is because here it's telling Watson is a system that can answer questions like, who is the CEO of IBM? That's not really what you want. You want something different when you ask a question like this. So if you use the natural language classifier and you say, who is the CEO of IBM, the same question. So now it will analyze this question and give us an answer. And in this case, it's very small, let me try. The resolution, unfortunately, I had to go to 1024 by 768. This is too much. But basically, it gives the right answer in this case. Ginny Rometty is the President and Chief Executive Officer of IBM. Now, I mentioned earlier that we use confidence, so I can say who is the most senior manager at IBM. I on purpose made up this question. It's not a natural question, you know. And now, if you ask this question, the system is not sure about the answer and gives you alternatives. And based on the alternatives, if you click on one that's the same, it will learn for the future that this question maps to that question. So this is how it can improve by usage. So this NLC is part of a bigger interface service we call Conversation, which is available on the web, and I would encourage you to go try it. I'm going to show you a 1-minute clip of it. It combines taking a question and assigning an intent to it, analyzing the questions and finding entities within the question. Like, for example, I want the FX50 model, you know, it's a specific little field called entities, and it has dialogue, which is interaction with the user. So let me show you the conversation demo. It's a video in this case. So if you go to Watson Developer Cloud, which is the Watson services, you see all our APIs. We have a lot of them. But now I'm going to focus on the conversation one. And if I go to the bottom of this page, with the low resolution, you know, the screens have to scroll a lot. So I will play it here.
Watson Conversation enables you to quickly and easily add natural language interface to your application so you can automate interactions with your end users. But let's take a closer look at what kind of interactions you can create and how simple it is to build them. This is a demo application showing you how you might automate a car using Watson Conversation. You could train it to answer questions or control functions.
So this is the user asking questions. And then the wipers turn on. A graphical answer, you know, a map.
But the most exciting part of all this is how straightforward it is to build. Watson Conversation comes with web tooling that enables you to easily configure how your bot behaves. This is done by using 3 key concepts: intents, entities, and dialogue. Here's a behind the scenes.
I'm going to stop here. This is available on the web. You can go build that demo or a variation of it. It's all available as sample code. Okay, I want to spend the remaining 10 minutes or so on talking about another cognitive service, which is based on information extraction technology. The tool is called IBM Watson Knowledge Studio. And the purpose of the tool is to allow developers to teach Watson different domains. This way you can port to various domains, like financial industry or insurance industry. And it provides an integrated environment to make it easy for training and customizing to a domain. And the most important thing is we are lowering the skill level required to build these NLP systems. So only subject matter expertise is needed. Somebody who understands the meaning of the sentences and the domain. We don't need software skills here. So just as long as you have an SME who understands the domain, the terminology of the domain, they can help build these systems. So I'll give you an example. These are accident reports tracked by the US government of all accidents that happen in the US. So there is typically a report about the accident. And the goal here is to design a computer system that will take the accident reports and analyze them into what we call a type system. So we would like to, this is where the artwork comes in. You have to design what information you want to extract from the content. So in this case, somebody decided they want the part of the car, the model year of the car, the manufacturer of the car, the model, the type of incident, the date of the incident, and the time of the incident. So these are the pieces of information, or we call them the type systems of entities of interest for the domain that you want to extract. And in this case, I'm showing examples from this particular report what the values will be for the various entities or mention of entities. So once you've designed the type system, you also have to find a corpus where the content is. There is no magic, right? You have to have a corpus where the knowledge resides that you want the Watson system to extract from. And then you can use an SME to do manual annotation of example data. And once you've annotated enough examples, you can push a button to train the machine learning system, and then you can deploy the system to do various applications, such as knowledge graph search and other applications. I'll talk about that in a moment. So this is an example of a system. Before it was trained, it used to think that 2013 here is actually a date, and Quinn is a person. Because this is the car domain, this is in use model, so it doesn't really understand the domain. After you train Watson in this domain, it detects that 2013 is a model year, and BYD is a manufacturer, and Quinn is a model. We in the US did not know about this Chinese manufacturer, so we had to look it up. So this is correct, actually. So this is the ability of a Watson system to learn from other examples and the use of context to understand new information. Once you have built a system like this using Watson Knowledge Studio, you can deploy it. So let me first give a demo before I talk about the deployment model. So I picked a news story from the news. This is about the hacked email of Hillary Clinton. And this model is a news-oriented model. So we're going to process this model. I apologize because the resolution, I don't know how it's going to look. We'll see. It might be too much information. Okay, let me make it bigger. So you can see here, there is a legend at the top. Let me show. Here it says by color what type of it is. Like green is person. So if I go down here, you can see, for example, Barack Obama is a person. So the system is telling us, I don't know if you can see it. Let me make it a little bigger. Okay, this is better. So this is Barack Obama. It finds he's a person. It finds all the mentions that co-reference to the same entity. So we call this co-reference resolution. So you can see that he is a rival, at the beginning of the first line. Rival, that's Barack Obama. And the pronouns, his connections. You also can see other people. So for example, there is somewhere here, I remember seeing McCain. I don't know where he is. It's so hard. I like big screens. Okay, so we were doing Clinton campaign, and here it is, John McCain. If you click on John McCain, it will go find it in its knowledge graph. In this case, this is built from Wikipedia, and it maps to the Wikipedia page of McCain. Now, interestingly, if we look at the relationship extracted, so we know he was a member of the Republican, and he said something, so we can find out various facts about the entities via the relations. In particular, if we go to this person here, there was a person, John Podesta, okay. So there was this person here, Tom Matzke, and this person is not famous enough to have a Wikipedia page, so the system detects it's a new entity, adds it to its knowledge graph, and it knows he is the president of Progressive Media. So the system is able to process new content and increase its knowledge graph as it's processing content. So this system can be built with Watson Knowledge Studio. You can, where is my slide? And then once you build the domain, you annotate example data, you can deploy it in two possible ways. One is called Watson Explorer, WEX. This is an on-prem solution from IBM to enable you to crawl an enterprise data, crawl all their content, integrate it all, and make it available through what's called 360 view, including the adding of machine learning-based text extraction. And you can also deploy it on Watson Developer Cloud, so you have now your own custom model on the cognitive services on the cloud, and you can use it as part of a other set of cognitive services. So this system, Watson Knowledge Studio, supports now all 9 languages of Watson. We have English through Korean, which was released at the end of September. So Watson right now has many services for these languages. So this is Watson Knowledge Studio processing some Korean in terms of the entities. The same domain I showed you in the English demo, the same semantic types. And you can find Developer Cloud at this website. I have a link to the 60-minute video to get to see a little bit of more description of what Watson is doing in healthcare. And there is a recent article in Wired magazine that talks about various use cases. I think that's useful knowledge to be aware of what other people are doing with Watson. And this is it. Thank you.